Welcome to the Contractors Innovation Podcast, where we learn and laugh and have a few meaningful moments. I've got a very interesting guest today. He's going to do a presentation. His name is Mehdi Hedari, a friend.
I'm here.
Interesting guy. Can Mehdi introduce himself and tell us a little bit, and Matthew in particular, a little bit about your experiences at Western and what you're going to show us today?
Okay, hello everyone. I'm Mehdi, and I met Martin a few, I think, weeks or months ago, and discussed different things. And one of the things that I think we both had some time at Western. So I did my PhD, part of the PhD research at Western. And then came back for a postdoc research program 2015 for 2-3 years, and mainly during these years I was working on developing a software at that time, a geostructural software initially for pile analysis and design, and then we tried to expand this as a geostructural type of tool with different types of soil structure interactions, things like that, for various applications, from pile under different types of loadings to bridge like piers and like pile column systems for bridge structures, things like that, incorporating different aspects. So it was mainly a kind of analysis design tools, but eventually that journey took us to different directions. After my postdoc, we went to the different courses here and there, but my main interest was developing different tools for automating a structural design. And then I spent some time, we got some funds, developed recently a tool for auto-generating reports, using tools like these large language models, and finally trying to create a web-based tool for different geotechnical and structural applications. So this is our current projects that we are working with my team at my company to develop a tool like that.
Mehdi, I want you to talk to Matt Janes a bit. Matt, can you hear Mehdi?
Yes, I can.
Matt's got a master's from Western and is going to be interested in some of the features of your design software, I believe, for excavation support. Are you able to show a demo on the screen and the same thing you did the day I saw it at your house?
Yeah, we actually I have to dig into some of the things because didn't prepare anything specific to be honest, to present. But I can show you some of the things that I have a bunch of I think presentation on the technical side. So but also I can show you a desktop version of what we're trying to develop. So if you give me 1-2 minutes, I can make myself ready for this items, but just trying to find the
in the meantime, Matthew, do you want to do a quick introduction while Mehdi is setting up?
Sure. Yeah. As Martin said, my name's Matthew Janes. We met back in the 80s when I was hired at Deep Foundations, and Martin was, I think, operations manager there. And so early in my career, I was actually, mentored by Martin in terms of excavation support, contracting methods. We built some very interesting equipment there. I went on to complete my master's, and then I was employed by a group called the Birmingham Corporation, and we developed propellant-based loading systems for structures, which was very interesting. We would create many thousands of tons of impulsive load using propellants and reaction masses to load structures vertically, laterally, bridge structures, etc. So I went all over the world doing that. And then I developed some very interesting high frequency vibratory equipment for resonant driving of piles and drilling of boreholes and soil investigation holes in construction. And more recently, I'm a design consultant for excavation support and permanent works. So major shafts for subways, structures, tunneling, that sort of thing. So very diverse, but a career of learning and great enjoyment.
Nice.
You have an MBA too, Matt?
Mm-hmm.
And
Yeah, I have an MBA from SFU, so I did took a few years and did that. That was in 2000.
Yeah, I'm a Raptors fan for the NBA. So NBA. Oh, NBA. Okay, yes, NBA. How you guys doing? Good morning. I'm Brian Couto. I'm one of the peeps over here. Martin and I worked together when he owned HC Macon. So I got to work with him for a few years. I got to learn a lot of stuff, and he's kind of a genius kind of guy. So I like hanging out with smart people so I could learn some more stuff. So really glad I'm here on the call too.
Oh, and Martin left.
And he's gone. There he is.
There we go.
Yeah. He just had to go around the world once.
Mehdi, did you figure out your presentation there?
Yeah, I have something like some of the things that I wanted to present ready almost.
Okay.
Yeah, I can start with a kind of a PDF that like on the theory side of what we have prepared during the postdoc and where the idea came from. And that was kind of something that it is aligned with what I think Mario has been doing like through these years. This is a tool like for that can be used for these type of applications that that I like to present. So I start with the theory side, and then on the software side, as I said, I can show you some of the features of the software and some of the capabilities. Again, on the software interface side, we had some progress, and I can show you some of the features. But I think that it's better to start with the theory and then jump on the like some of the capabilities of the tool that we developed. I think I should be able to share my screen.
Yep.
Yeah.
Oh, is that you when you were younger?
Oh yeah, that is my 7 years old. So this is like I can probably do this. Yeah, I have to take this from. I think I
So
shared.
are you a frequency domain based guy building on Novak, or are you sort of finite difference or FEA?
Sorry, is it a question for me?
Yeah.
Can you say it again?
Are you a frequency domain fellow building on Novak's work, or are you finite difference and time domain?
We work based on the Winkler Foundation, nonlinear Winkler Foundation, Novak also. So Novak worked mainly on the so the professor that I was working with, Hisham, was working Elnagar, was working with Novak on those frequency domain, for like vibration and all the like cyclic or dynamic loading. And then I extended my work to not only like dynamic, but also cyclic loading and also seismic. So, but yeah, very, very close to that. But that was a kind of semi-analytical approach that Novak pursued to solve the problems. We combine that with some other like techniques to incorporate more features of soil pile interaction.
Right. Okay. Thank you.
Yeah. And what I'm trying to do is to share my screen, but when I share, I think that I have to share this one. And I think now
Yeah,
you
it's working now. Yeah, it's working now.
Can you see my screen now? Like,
Yes, sir.
Okay. So, like a little bit about this solid structure interaction. I think that this is one of the, I think the thing that we need to incorporate when we design these type of structures, and some of the common practice that I've noticed that they do is like most of the like let's say basic tools that they use for analysis of laterally loaded pile or shaft, they are not like incorporating some of these features. So this is what motivated us to go and develop this let's say framework. Mainly, as you can see, for laterally loaded piles, but we added some features for the axial load as well. And we are talking about different types of loads, not only the static, but also dynamic, seismic, and incorporating different, like even free field. And geostructural analysis program, this is what we called it, GSNAP. It was during a geostructural nonlinear analysis program, and nonlinearity plays a significant role here. And again, I did several research on this topic of nonlinearity, and I'm talking about different types of nonlinearity from structural, geotechnical, and also geometrical nonlinearity. And this is what I'm trying to explain here. I don't want to get into the structure soil interaction. I think that most of us are familiar with the importance and how it can affect the results, especially for lateral loaded pile. And one of the things that I noticed, at least through years of like working different tools and software, was the lack of or gap between the structural work and geotechnical work. Like most of the even highly advanced like geotechnical tools, they lack some of the structural features, and vice versa. When we work with the CSI or other advanced structural tools, their main focus is on the structure and not the soil part. So this was the challenge was to like kind of make this bridge between these two fields when we have also all these features, most of the important features included. I don't want to go again through the solid structure interaction part, the key factors, important parameters, bearing period or damping, and as Matthew might be probably familiar with, Novak worked on these parameters like damping or stiffness of the system, which eventually affects the period of the system. But on this topic, we have different approaches. Some of them are very extensive and expensive, and some of them are too simple. And usually we are in ideal case, we should be somewhere in between. But most of the time, I think that what I learned, even from the codes and guidelines, they try to lean into the very basic and simple type of analysis instead of the advanced. And when I'm talking about advanced, I think the main thing here is the cost of analysis and also the time. We have different types of analysis, as you can see: force-based, displacement-based, response history analysis. For that particular, for instance, example for piles, most of the time they go, especially with the like tools like SAP or CSI tools, this wing tilt model, they go with force-based, but probably the displacement-based approach might be a better option. These are different modeling approaches. As you can see from the direct analysis approach, that we have the structure and the entire soil medium modeled. And as you can guess and see, this is very expensive type of analysis. It requires too much time to perform the analysis. And most of the tools, even like if you look at Plaxis, FLAC, or other tools that we can use for these type of applications, the problem is that some of these or most of these on the structural side are very limited in modeling capability. We have a substructure approach. That we have only and this is a kind of the Novak's work or Hisham work. After that, some people work on this approach. They remove the soil medium, replace it with some spring and dampers, and then eventually they rigid base model. This is what we have mainly in structural tools. Like when it comes to building design, we just make it a rigid frame, and then flexible based model. This is what we have also we can use, and this is I think what we came up with eventually in our tool. Structure plus with linearity and non-linearity of the springs, and also some other aspects to simulate the model, replace model with these non-linear Winkler foundation springs. Bathtub model is another one that we can go with. Even it allows the medium, for instance, when you have earthquake, the entire system can also on the kinetic interaction, we can also incorporate those.
So basically what I'm understanding, this is like a foundation, but instead of having gravel around it, you have springs so that it could take certain shocks, like an earthquake or something. Is that?
Yeah.
Okay, cool.
And we have two different types of interactions actually when it comes to building. We have kinematic interactions, the free field, like when we have earthquake, we have the soil that is moving, and then it applies some load to the entire sub and superstructure. And from the inertial also force or interaction comes from the weight of the building, right? And we usually ignore the kinematic interaction, and this could be accurate if you don't have interaction. If you don't have that significant soil pile interaction, that could be minimal. But if you have liquefaction as a liquefiable soil, or in case of a slope, you have this kinematic interaction. It's not the inertial mainly, right? So you have soil moving around during the free field movement of the soil during the earthquake, and this movement apply loads pretty much like when you have a slope or even when you have for instance excavation. The movement of the soil cause that load, not we apply a load to the structure, right?
Yeah.
So
even if one of them moves, the springs in theory should at least push it back, or
those are models.
put it back in place.
Brian, that's a model. In other words, to analyze it, he puts springs in the computer, but it's not.
So the reason that we remove the soil medium with a spring, the main reason was this. They noticed if you remove the soil with spring, and then you apply the load to the foundation or a structure, it can mimic the results. Is it theoretically 100% accurate? No. Does it have a solid foundation theoretically to solve the problem? No. But does it give us the good result, the right result? Yes. And I can tell you why. They back analyze the spring constants from the full scale testing, and that's why it works.
So the springs are as like a testing tool, like they just measure how much it moves, or does it actually
the
help?
spring
It's
is
in the computer, Brian. It's
yeah.
not actually in the field.
It's not actually
Yeah.
spring. It is replacing soil with the spring in your model.
Mm.
I
So it's
got
like a coded spring, basically. Like it's like a piece of programming that's running as a spring would if it were in the ground, but it's in the computer. Okay.
Low deflection like a spring,
Yes.
but it's arithmetic more so than physical presence in the field.
Yeah.
Yeah.
We represent soil with these springs. The other way that we analyze soil, like the way that how we analyze like buildings, we don't go and create the entire like beam, right? We just draw a line or simulate a line, and this line represents beam or column,
Yes. Yes.
right?
Yeah.
Or a surface, like we call it shell element, right? These shell elements or membrane elements, they represent floor, but they are not floor. They don't have thickness. It's a shell element, right? But they can simulate the behavior of that structural component. When it comes to soil, one of the approach is to replacing the entire soil medium with some springs in your computer model.
Got it.
The other approach is finite element model based like programs. They simulate the entire medium. But as you can guess, like going 20, like 100 feet, 100 feet, 200 feet, modeling this volume or this area of soil would be very extensive when it comes to the analysis cost. So can we find something in between to not only be accurate, but also less costly in terms of analysis? They came up with this spring concept, and they call it Winkler spring, or you know.
Because that was probably the guy's name who invented it, no?
Yeah, I think 18 something. He was the person who used the or replaced or represented this with a spring like
Yeah.
So these are different models here, as you can see. Analysis of a laterally loaded pile, and this pile could be the caissons or any system that supports the excavation also, because again these are all or mainly laterally loaded substructures. As you can see here, this is the concept of a spring, right? You can replace soil in your model with a bunch of a spring, and this spring can pretty much model or find or represent soil, and you can find the internal load in your structure like pile or foundation, and also deflection of these systems. So that was the main concept. One of the factors that you can see is the subgrade reaction modulus. This is what we use, either if it is vertical or lateral. And this subgrade reaction is the key factor. The subgrade reaction, as you can see here, like this is a like example. This is what they call it, PY curve or TZ curve. I don't know if you heard these two terms like for pile design. Usually they, as I mentioned, they back analyze these like from full scale testing. They do the back analysis and try to find these curves. And as you can see on this corner, this is like one example of PY curve. And sometimes they simplify these curves like that. And as you can see at each depth, in case of like piles or vertical laterally loaded piles, we have different PY curves at different depth, and these are for different types of soil, different conditions. They came up with these different piles. These different PY curves. As you can see here, the PY curves has a linear portion, and then they consider this as a elastic fully plastic model. But this is not elastic fully plastic curve. This is a nonlinear curve, and this I did some research on that topic, and it can have a significant effect on the response of the pile, the deflection that you receive, and also the internal load that we can estimate. So we have these piles, as you can see, even the initial portion, which is the K0 number, varies with depth. Different types of soils has different conditions, but that was our main goal to kind of not only estimate but properly simulate this when it comes to analysis. We have inelastic.
Mehdi, can you show us the design software where you show the layering of the soil?
Yeah.
Can you show that? Because that would be good.
Yeah,
I'll
I'll get to that. So we have these parameters, as you can see. Soil pile gap, that was one of the factors. Cyclic degradation, hardening, and these are all like for the and this is what we actually so initially that was the part of the GeoSnap tool that I initially used MATLAB for that. So in this tool we have different layers, we can simulate different layers. That was the very basic version, and in this version we not only like this is the model that we use for cyclic or dynamic loading for the piles, for the soil pile interaction, and also we use this model for nonlinearity of the structures. Different types of piles, soils, and load can be modeled here, and this shows a difference when it comes to like linear and versus nonlinear type of we did some validation, full-scale test results, nonlinear cyclic response. We can, as you can see, model different oval shape or S-shape type of responses. And this is another validation we had with the tool. But on the interface side, and again, we can also use this for the full seismic load when it comes to modeling different type of responses for free field type of this is what I was talking about, multi-excitation or multi-support excitation when it comes to earthquake. And this is the kind of the most advanced type of analysis when you have not only the load applied from the superstructure, but also each of these ends supports can also we can apply load multi-excitation like movement to the end of each of these to simulate both kinematic and inertial interaction. On the interface side, and again, as you can see, we did some sort of analysis. On the interface side, we had this tool, like I initially started using MATLAB for all the codes to see if the results are accurate. Some of these or most of these results are generated using that tool in MATLAB. Eventually, on the interface side, we needed some desktop version. MATLAB is the greatest tool for like validating results, but not the best for developing software. We used C# for developing the interface, and this is actually what we are working on the past few years. I can probably show this. You can see it here, right? Can you see the software now?
We have a screen.
Yep, I can see the software.
Let me switch the screen. I think that I have to jump on the. You can now see this screen, right?
We're waiting for it to come through. I was able to see the software on the previous screen. Right now, no screen is shared.
Let me share this one because I have two screens. So I think
there you go.
This is the presentation screen.
I'm going
Yep.
to check this here. Yeah, here.
Okay. Yeah.
So this is the C# version of that, and in this C# version, again, basic at this time, but you can change the units and all the other parameters here. On the definition part, we have material sections and phases. What I was trying to do is to also incorporate different phases of, for instance, excavations. And material side, section side, and with material, we can go with different type of material, different types of parameters and models. And I kind of included most of the features from different tools to make sure that we have the and on the section side we have and this is initially started with GSnap, and that tool, I try to model most of the commonly used pile cross sections or pier cross sections for in this version. And then this is the soil layering. So we call it strata, and we can apply different add infinite number of layers, defining water table and other parameters. And also apply or model different types of piles in this particular case. Using the sections defined, the material is used in the section, and then we can apply these or model these different types of elements in. So when we reach to this point, for some reasons we stop, and the next phase now that I'm working on the web-based tool. So we didn't want to proceed with this desktop version, and I tried to decided to transfer everything to a web-based tool, and we have the engine on the from MATLAB codes, and we validated all those tools, different applications. On the interface side, we came up with this workflow or interface, and now I'm trying to transfer everything from this to a web-based tool.
Cool.
So we have about 4 minutes left. Does anyone have any questions for Mehdi?
You're saying we could stop the recording and can stitch it together in editing, yeah. So
Yeah.
it's really an introduction. I wanted to get Mehdi and Matt Janes introduced each other because this was pretty technical, but we want to try and you talk about a desktop version, right? That's what no web-based version.
Yeah.
So I wanted to try and help Mehdi with I've got some programmer references and a pretty good website guy, but then also web-based. He's looking to build a tool. How many hours do you think it would take, Mehdi, to build a tool with your guidance over it? Let's say 20% of the time. It might take. I'm thinking. What do you think? How many hours? It would be an ongoing.
We did this one as well. At some point, I decided to use another tool as well for the interface. This is also, I think, that what we developed for, I think, This is also
I
a.
don't think so.
Can you see my screen now?
Yes.
Yeah, this is
This
the
is Gmail right now.
message that I'm receiving.
I don't know how
There's
it
no
goes
problem,
back to
but
the.
would not load file or
Yeah,
asset.
here. So this
That's
is
good. I don't know
also
why that happened this time.
similar tool, not similar, but the same application. So if you have any excavation or any pile design, we also use this or develop this plugin for Revit. So if you're familiar, Revit is like a beam-based tool for different applications. So we can, on the modeling side, because I didn't want to spend too much time on the interface side, so we also develop this basic tool for like we can import loads from structural tools and model different types of like a structure and also model the soil. This is what we developed. Like this one, we spent like 2-3 months to create something like that. If you have the interface and if you have the base model with what we have, and we also wrote some of the codes on the web-based part. So we have some like web-based programs that we can transfer everything from this desktop version to that one. And my guess is 4 to 6 months is needed for a full-time like programmer, and because we need a front end and a back end at this point. The front end part is the interface, and they have to develop the interface exactly similar to what we have in the desktop version. And on the front end, because it's a web-based program, there should be some connection between dots, like the engine that we have and the interface. They have to transfer all the data from the engine, and also the interaction of the users with the tool are also important. So we can't go C#. The main reason that we went with C#, transferred everything from MATLAB to C# was this. This plugin was developed before that desktop version. The reason that we use C# is Revit uses only C# for API. So for Revit API, you need to use C#. And that's why we transfer everything to C# and Visual Basics. Now, I think with the I had some like discussion with my friend who is working with us on the computer side.
Welcome to another episode of the Contractors Innovation Podcast, sponsored by CH Shotcrete Inc. We're happy to bring you these podcasts in an education and knowledge sharing format. And we look forward to hearing from you. Email me at martinh@footprintengineering.ca. God bless, and may you have a wonderful day. The art of excavation support is such that, you know, when somebody's been doing it 30 or 40 years, they tend, with an elite firm like Isherwood, they tend to know that, you know, passive pressure, an active pressure of 0.25 and that type of thing is universally used. And then it really becomes efficient for the contractor if you can use a 18 at 55 or 45 beam versus a 24 at 68 beam. So our savings are usually in steel and volume of concrete that we try to help the developer, or let's say to get low on a job, we would typically have an advantage with someone like Isherwood. Although Isherwood, you know, they're not fast. They tend to be busy, and so speed is always an issue. When I did HCM, I started RWH engineering, and I had a really good guy, and we had Tom O'Rourke, structural guy, and Nader Ansari helped Jason Weck develop. And now he's the president of the contracting company, and he pretty well knows all the numbers as an engineer. He's got a staff of young engineers. So integrating or embedding the engineering within the contracting is what we want to try and do in CH shotcrete as well. And,
So the
Matt,
thing is,
Brian,
yeah, with this tool, I think that my ultimate goal is this, one of the reason that I was not too like excited to present this as a software is I know that it requires 6 months to get to that point, right? We need 4 to 6 months to get to that point. And one of the things that we are working now on the large language model, as I mentioned, is we are trying to optimize the design, right? So it's kind of, we have the engine, we have the interface, and we can optimize, and using AI. That person that I'm working with is AI expert. Try to optimize the design of these type of systems, comparing like 10 different, for instance, solutions on the cost wise, like the constructability, and then come up with it. But I think that on the interface side, which is the fancy part, is like the presentation on the interface. So I think that we need to spend some time on that part. And I think Martin is frozen.
I have a question, because you mentioned using like a large language model. So like, are you using ChatGPT or anything like that? And what's that experience been like using that to help with the coding?
To me, that is a kind of a cycle. We use that for report generation mainly, but on the AI part, we try to use that for model optimization on the engine. But the thing is that web-based tool works like as a data entry point to generate report at some point, like based on the design and everything that we do in this side, on the analysis and the engine side. But yeah, for optimization, we need to use some sort of AI to compare different solutions.
Got it.
And make it more competitive when it comes to the design.
Can you hear me, Mehdi?
Yeah.
You know the difference between.
Oh, now we can't hear you.
Frozen.
Martin, you're frozen if you can hear us. Hello?
In this soil.
Oh, there we go.
They'll pretty well know within 15 minutes what the pile size is.
Yeah, sorry, Martin, you froze through that whole conversation. We didn't hear anything.
Well, that's probably a good thing. I don't know. For some reason, my internet is wonky. It's going in and out. You getting me sometimes?
Yeah, it's tough.
What I was trying to say to Mehdi is precision is the software and accuracy is the experience. So the experienced guy, he's never going to save a lot of money for the contractor with precision, but he'll basically, by knowing areas of Toronto and different areas of soil and having built many jobs, they'll pretty well nail it in the first 15 minutes in terms of the contractor comes in, does a handover to the design build engineer, and here's what I bid, and you hope that the guy.
No.
Yeah, just to add to what Martin's saying, yeah, that's true. As soon as I get on site, I know if I'm in Cambridge, there's lots of rocks, the bigger rocks when you work there. If you work in parts of Brampton, you got shale, right? So shale is a totally different application. You go to some places, it's all sand, right? So you have to, depending on where your location is, how your ground is, I guess that's how you would go with your
foundation.
Can I
add something here? How you can pass this experience to another engineer?
Yeah.
This is the key, right? As a firm, because you are irreplaceable. You need to be replaceable, right?
Yeah.
You have to.
We're not gonna live forever. So who's gonna pass? How are you gonna be able to pass it down, right?
This is the point. That is the main reason that we developed that tool, the web-based tool. Now you log in, you have a history of work across South Ontario, right?
Imagine if they would have had that technology when they built the pyramids. You know, we would still know how to build those things. You know what I mean? Like that's what the purpose of this software is so we're able to pass it down and not lose this technology, right?
Building information model. This is what I teach at Western and also through years at different colleges. BI. Information modeling is the key, and that's why we transfer everything from Office version to web-based version.
Very
So
cool.
now you have all these borehole logs across the region or a city or like the country, right? Storing the data, soil data, groundwater condition, everything.
Yeah.
Right?
Yeah.
So
Yeah.
you have history of boreholes across a region
In that area, yeah.
in that
Exactly. That
area.
makes sense.
And on the reason that we had those advanced like structural modeling tools to
Yeah.
have all the library of files with the cost, with the manufacturer, with the availability, with this, with that, right? It's about information, right?
Yeah, because right now we would have to bore every site. You have to bore a hole and you got to test it all, and all that takes time, correct?
Exactly. Now, but one of the thing is this. I was working somewhere and I reached out to this guy and said, you have lots of data. Why you don't embed all these data in a platform that
Yes.
before going to the site, you can tell, and it's not the most experienced person in your team, everyone.
Yeah, everybody
Just
knows.
just put a pen on the Google map, your Google map, your system, and
Yeah,
then tell you what type of soil you may encounter.
correct.
And based on the type of soil, you will have a library of like solutions out there. But this is
Yeah,
the thing. This is the thing. You can come up with a solution based on your experience. But
yeah,
what if instead of deep learning, which in the AI part that requires lots of analysis, we do a short, shallow learning.
yeah,
How? Simply do a simple analysis. You have the soil type and you have a bunch of different pile options, right?
yeah.
Excavation solutions. Quickly do some simple analysis, tell you which one is the most cost-effective solution for that specific job site.
Yeah. Instead of having to start right from scratch every
Ex-
time, right? And then this way you keep your information. So that's very good.
You
I
want
like
to
that.
bid for a project,
Yeah.
but you want to bid from thin air, right? You don't want to
Yeah.
just throw a number. Yes, you are experienced, but even for the experienced guy, they have to go and see what type of soil they had in that
Of course.
specific area, right?
Yeah.
You have to do
Yeah.
your own research. This simplify that. This helps you to just by pinpointing a location in your map
Yeah.
from your previous data, it can tell you what type of excavation might work better for this job site. And it can help you to do some cost estimation as well.
100%. Because Canada is so huge and so vast, and you could be working an hour from each other in different places, and the soils be totally, totally different.
100%. And this is the thing. The reason that they talk about all these like technical and advanced, the reason is this. We have the tool to do the analysis, right? This is the advanced tool. We can even to that level of accuracy, we can do the analysis. It's not important for contractors. I understand that. On the solutions, we know what are the solutions. This is you can go with Raker system or Kson or this and that, and this each of these come at a cost, right? But the thing is this, you can embed that type of information into your model. So this interface allows you to put the cost, manufacturer, availability, this, right?
Yeah.
So you can have everything embedded into your fed into your model.
And so this is what you're saying, another 4 to 6 months to have it where you want it to be.
But it doesn't happen in a vacuum. You need the location.
Of course.
You
And then
need a borehole log.
would this be just for the company that uses it, or then the other companies can also buy into
Any
this?
company. That's why we need that hub. We need
then you
to
can
let
share.
you. We need to let you the two tricky things here. We need to let you as a contractor to sign in,
Yeah.
put in all the information from your previous projects, and no one should have access to that information because it's gold.
Yes.
Mhm.
You don't want to share your data with your competitor.
Correct.
So you sign in there, log in, put all the borehole logs from previous projects, the cost, the solution. You can even create a simple model of that.
Yeah.
And then with the large language model or the AI model that we develop, you can compare different cases, and we do some basic analysis as well in the background.
Mm-hmm. And then is it going to be set up so that, say, for example, I'm testing all these different spots and I'm going to put all that information on the app. Say I want to sell that information to another company. Would I have that option?
Yeah, you can
Right.
like if you want to have a like rough cost estimate, which is very, very close to what we eventually get. You
Yes.
can do that.
Yeah.
So if you want to bet or if you want to even sell, like I want to know what type of soil I have, but I don't have that experience. I haven't done like
Yeah.
I haven't had like dig 20,
In that.
200,000 boreholes in that area.
Correct.
I reach out to you as a person who have done extensive work on this area
Yes.
and then ask you, can you please, but you need a tool
Yeah.
to feed your data into that, and then we use some sort of interpolation between these points, and then it gives you even the soil layering.
Yeah. That makes sense. That makes sense. There's a bunch of building everywhere, but we always have to take a sample first just to see what we got underneath our feet.
But what if you had another projects like maybe 1 mile away from this?
Yeah, it would give you a rough estimate at least of what you should
At least
expect.
for the soil,
But-
and we use the same technique for MOE well data for the
Yeah.
soil stratigraphy or water condition and this and that.
Yeah, I
This
guess
would be
even
part of
oil
it.
companies could use this as well. Any kind of
Yeah.
drilling, any kind of foundations company, this would be very useful for a lot of these different types of industries.
And also you have your custom type of library of solutions with the cost
Correct.
because it varies, right? You use this material, you have this provider,
That
it's not available in your area. So we can compare all these different solutions, but
yeah,
the solutions and this came to my mind like when I was doing a structural design back in my home country. So I've been doing lots of designs, structural, but I noticed that when I go to the site, the contractor or the engineer with experience can tell without any analysis what type of beam and even the size of beam based on some basic information. So
yeah,
it came to my mind, what if we can put this in a program? The experience,
Mhm.
right? We need to sort of like get this experience and then transfer it to the software.
I remember we were digging. So on the 403, we're putting the overhead signs, the big highway signs, and we have to dig down 36 feet into the ground. And if we would have had that information, this one hole we were digging, we were down about 20 feet, and all of a sudden, groundwater came into the hole. And we're like, what the heck? It started filling up the hole with groundwater. If we would have known what it was in that area, then we could have already prepared for that.
Yeah.
Right. Instead of being surprised and then having to deal with it on the spot. Right. Because we're working night shift. We have trucks coming in at a certain time. Everything's very strategic. Right.
Yeah.
So by knowing what the base was, by knowing what's under our feet would have helped out a lot. Right. We'd at least not get surprised.
But and the other thing is you might have like maybe involved in 10,000 projects, right? Martin, maybe a million. I don't know how many projects you have done through these years, right?
10,000 actually.
But where are those? Where are the information?
Yeah, it's just all up in here.
In here, right?
Yeah.
But there's lots of people like me that are in the big companies, and they're the chief estimators, or let's say the lead. We used to call them lead estimators. They're project managers who've worked in all parts of Toronto or London or whatever. And the architect and the structural engineer might call them or not call them, but usually the architect and engineer have worked in those areas also. So they're using the boreholes, which are done before.
It's not even
where they
only the
get drawn.
boreholes. I'm not only because the borehole, if you go like the Canadian government, they develop something very similar. So you can like go to this website, like it's a Google Earth. I can show you actually. This it shows all the previous boreholes from different jobs and the Google Earth map. And this is what we are going to develop. It's not that complicated. The idea is simple. You add all the information, and that's one of the reasons that I try to develop a software or to extract the information or to feed information into the model is it's not just for the borehole, because you need to use the borehole information for your design, but you don't want to get involved in design to that high level, right? But if you have those previous projects and you can fit this into your model as a borehole, like you can get the borehole, like the soil stratigraphy, layering of the area, groundwater condition. It's not that complicated though. And you have experience on the construction side. You have this, that solutions, right? You have several solutions and you can use. The thing is this, for different projects, what if I give you the most cost-effective solution
as well
in 2 minutes?
Yes.
Right? And this is very, very close to what the engineer down the road is going to design. You just want to bid. This is the solution, and it's 90% close to what they eventually come up with.
And all that's designed just with the app.
Yeah.
So that it takes the thinking out of it.
Yeah, and you have all the previous projects information is stored in the app and will be used for your future projects.
For generations to come.
For generations to come. And you don't lose information, all in there, and people can just dive into that and see what is going on there, right? And if Martin with 30, 40 years of experience leaving the company, he can leave his
information there
in there, right? And we can use that experience for the next generations.
Yeah.
So question, I'm not sure how well like these companies keep records, but I'm assuming they have records of all this information from past projects. Would they be able to just like copy all those files and like dump them onto the interface and it'll sort through it and everything? Yeah.
This is exactly what it is. So
you could probably use
file reader, and then they just scan it, and then we interpret all the data and then feed into the model. So we have different ways. That's why the one of the reasons that I was hesitant, and I actually didn't want to enroll in this podcast is this. I know that we need to demonstrate that professionally to the audience. It's just it's not an idea. We develop different pieces of this tool. We have the interface. I know how it should look like. On the engine side, we have that one. We are working on some of but it needs back end, front end. For that one, we need the back end.
Yeah.
Well, you got a head start before this podcast gets aired, so you better.
That's why I didn't want to.
Right? I'll tell you a story. In the 80s, Deep Foundations had a board, and the blue flag was a prospect. That means they had a borehole or a soil report for that. And the red flag was, let's say, a contract. And that pin board eventually got done, but that information was manual on the wall and quite useful, really, in terms of today to automate that. You know, like you say, maybe the database exists where every borehole is captured. Again, interpretation of, that'll drill open or that won't drill open. You know, sometimes it's the 10-year estimator that says, I wouldn't bid 9 holes a day there. I would only, you can get the job by bidding 7. So you try to get as much money as you can every time, right? And
because the easier the soil, the more holes you can make, right? So by knowing that information, you know what you're doing.
Usually drier. The drier the soil, water is the enemy of our trade, right? It's generally water, because if there's water or layers, then you have to case it because you have to put concrete in to dry, right? Or you drill underwater.
Yeah, we just filled it with concrete, and then as it was drying, you could see all the concrete start to sink because it was pushing the water eventually down, right? But we lost on 32 feet, we lost almost a foot, like pushing down because of all the water. It was crazy.
You mean, yeah.
When we were doing the caissons for the signs, for the overhead signs, we pumped a bunch of concrete in it, and then eventually as it was drying, it would start to set down, and it took forever to dry because of the water. So if we would have known that there was water there before we started, we would have got a drier mix, right? We would have brought in a drier mix, or maybe a better, we would have figured something else out, right? But
sometimes water in the city comes from services that have been leaking for years, and you don't know, right? The guy doesn't pick it up on a borehole.
Yeah.
Anyway.
No, exactly. Because a borehole is only this. You know what I mean? So, well, that's cool. That's very cool. But yeah, I understand that you got to get you got to get the app or whoever you're going to make this. There's a lot of moving parts to it. So,
Mehdi, are you saying that the boreholes, there's a log of boreholes in Ontario that you can get?
Sorry?
Are you saying that the boreholes are logged in Ontario and you can access that?
We can find those, yeah.
Yeah. And Google Earth has them as well. So you would have all of that information that you have access to, you'll have it onto your app.
The funny part about these boreholes is just they have only the soil type, not the soil strength. SPT numbers are not there. And this is what you need for your design, right?
Yeah, flow counts.
So that's why the companies should use their own probably database to.
Well, that's what happens practically. Practically, the estimator who knows the area, who doesn't want to lose money, will bid it a certain way. If he gets the job, he may try to refine it a bit with the right engineering partner. We don't really bring engineers in and pay them during estimating. But when you're fully integrated like we were, we could give a chief estimator or an estimator a section that would be accurate from the engineer within the company. The engineer within the company, we started Art of H Engineering, and they were always in the same office. So we broke the mold of it. Matt James' partner, or let's say is the founder of Issuwood, or not the founder, but the president today. He's Nader Ansari. Anyway, we'll have to meet Matthew on another Zoom. He was listening carefully, but I'm sure he's been there, done it in terms of trying to make something theoretical or something in the way of a tool that you can press a button. But when you press the button, the liability comes with the interpretation of whether you trust it. Right?
Yeah.
And so somebody's got to bid that with more holes per day, or, it's really not a risk we take, in terms of relying on software to when 30 years experience can be quite useful, right? On a street corner in Toronto. I mean, if you go to Bay and Yonge, we know the soil. If you go to Front Street, we know the soil, North York, different areas of Oakville and Toronto and Burlington. But typically it's glacial soil. So you're looking for that silty pocket, something that won't allow you to drill open. Now, remember I was telling you about the self-drilling bars, Mehdi? They're quite forgiving because you can start those, not lose ground. You don't need casing, and you can get high friction by drilling with grout. So certain things won't change really. A lot of things big companies are doing today, they're just smaller companies just copy them, and people leave big companies and start small companies, right? So anyway, that was good. But I don't know what you do, Mehdi, with the edits, but probably could do, cut and paste something that isn't too choppy, maybe, with everything you've recorded, Dante.
Oh, yeah. I'll clean it up and I'll put it together. Maybe I'll put a small little commercial break in between each edit and cut, and then we'll just go from there.
That works.
Yeah, in the show notes you could probably label maybe maximum 5 sections of like basically shorts, right? You'll
Yeah.
get mismatches shorts, but it'd be worthwhile, I think, to
For
see
sure.
it.
Yeah.
And so
All right. So we
thank
can
you
go ahead and
for
no
your time.
problem.
I'm glad we got it done, even though it was a little bit. I had bad reception through the whole thing. Bad internet here today. Thanks a lot, guys.
No problem.
Well, I got my next show is August the 8th in Toronto, and I'm gonna be the Macho Man. Mehdi, are you a wrestling fan or
He's
what?
a comedian, Mehdi. He's part-time. He's a laborer, but he's a comedian at night.
Yeah, and so have you seen this? Look at this. Oh yeah, the Macho Man jacket, full in effect. Yeah, because we are the greatest podcast ever to be on the internet. Yeah, we're the cream of the crop. Yeah, cream of the crop.
Awesome.
Is there any money in stand-up?
There is when you're good. Yeah. When you're good, you're really good. We're doing a fundraiser for Cambridge Hawks for the hockey team. So I'm going to host it, and we have Mike Rita there. I think Dante, you're going to be in that show as well with Mike Lewis.
Yeah, give me the dates for that one.
Yeah,
we were
I think
talking
it's
about it.
November.
So yeah.
October. And so it's fun, but you have to, if you want to be a stand-up comic, you have to love it, because the beginning is hard. You know, like when we go to work at work, we get paid by the hour, correct? But when you're a comedian starting out, a lot of times you're starting out just to get on stage. So it's tough.
The most I think how can I describe it? You should be like have a nervous of steel to get there.
Oh yeah, you need nerves of steel. You have
Yeah.
to. You can't care about what the audience is thinking. You have to just be there for yourself, do your thing, and that's it. And just stay on track. Nobody knows if you made a mistake or if you didn't say the right thing. You just have to be fun, and you have to have fun. You know what I mean?
Yeah.
So that's pretty much what it is. So
Yeah.
I'm off to Toronto. I got some videos I gotta record today again, so we're gonna do some more content and stuff. But this was fun, guys. I learned a little bit, and let's do this again.
You know, Brian or Dante, you could cut shorts out of this one and have a few shorts.
Yeah.
Of Laugh and Learn Brian. You know,
For sure. We'll
This
do.
is the Laugh and Learn podcast. Yeah.
Thanks a lot, guys.
Have a good one.
Thank you.
See you later.
Bye.
Yeah.
Baby, I